Hello everyone, in this video lesson we will be discussing the technique in evaluating the second type of improper integral, and that is with discontinuous integrand. So here we will be dealing with functions that are discontinuous on a certain point on the given interval. So we let here a function f of x that is continuous on the closed interval ab except at some point in this interval. That means that we will have three cases. Okay, that is when the function is discontinuous on the leftmost endpoint, that is at A, or the rightmost endpoint, that is at B, or at a certain point on the interval AB, that is an interior point of the interval. That means that we will distinguish three cases here. So in this video lesson, we will focus on case 1. So that is when the integrand is discontinuous at the lower limit. Okay? So case 1 states that if f is continuous on the interval AB, but is discontinuous at x equal to a, therefore we are dealing with a function discontinuous on the lower limit. Okay, a, and the integral of f of x dx from a to b is now equal to the limit of the integral of f of x dx from t to b as t approaches a from the right. So therefore, we will replace a by t, okay, and we will evaluate the limit, okay, as t approaches a from the right. If the limit exists, then we have a convergent integral. If the limit does not exist, then the integral is divergent. Okay? So let's try to consider this example. We have the integral of dx over the quantity cube root of 4 minus 2x raised to 2 from 2 to 6. So as you can observe, at x equal to 2, our function is discontinuous because our denominator will become cube root of 4 minus 2 times 2 raised to 2. And this is just equal to 0. So we will have a undefined function at x equal to 2. That means that our function is discontinuous at x equal to 2. So therefore, since it is discontinuous at x equal to 2, we will apply this technique. So we will replace now t sa 2. So therefore, we have, this is the limit of the integral of dx over the cube root of 4 minus 2x raised to 2 from t to 6 as t approaches 2 from the right. Okay? So first thing that we will do is to solve this definite integral first. So we will have the integral of dx. Kopyahin lang natin over the quantity cube root of 4 minus 2x raised to 2 from t to 6. Okay? So in this case, we will first apply u substitution para mas madali siyang isolve. So we will let u be equal to 4 minus 2x. So from that, we have du equals negative 2 dx. That means that negative du over 2 is just equal to dx. Right? So from that, we now have this is equal to the integral of dx is negative du over 2 all over the cube root of u raised to 2. Now, since we replace the variable x with a variable u, so therefore we need to change our bounds. So when x is equal to t, we have u is equal to 4 minus 2t. Okay? And when x is equal to 6, we have u is equal to 4 minus 2 times 6. And that is equal to u equal to negative 8. So from that, we now have the integral of negative du over 2 over, I can rewrite this as u to the 2/3. Okay, from 4 minus 2t to negative 8. Okay, so from that, evaluating the integral, we can have negative 1/2. Ilalagay natin sa labas. So we have negative 1/2 integral of du over u to the 2/3. Okay, from 4 minus 2t to negative 8. That means that the integral of this one is just, so kopyahin si negative 1/2, and we have u to the, this is just u to the negative 2/3, right? Kung iaakyat natin siya, so plus 1, so that is 1/3 over 1/3. Okay, from 4 minus 2t to negative 8. Okay, so from that, we now have negative 3/2. Okay, u to the 1/3 evaluated from 4 minus 2t to negative 8. So that means that we have negative 3/2 times negative 8 raised to 1/3 minus 4 minus 2t raised to 1/3, right? And from that, we now have negative 3/2 times negative 8 raised to 1/3. That is just cube root of negative 8. So that is negative 2 minus, kopyahin lang, 4 minus 2t to the 1/3. Okay? Or that is just, we distribute this negative 3/2. So we have 3 plus, we have 3/2 cube root of 4 minus 2t. Okay? So we will now substitute this to our integral here. So we now have, this is equal to the limit of, again, that is 3 plus 3/2 cube root of 4 minus 2t. Okay, as t approaches 2 from the right. Okay, so evaluating the limit of 3 is just 3 plus, okay, we have 3/2. Then if you will substitute 2 here, since this is from the right, so this is defined, so the limit will go to, so 2 times 2 is 4, 4 minus 4 is 0, cube root of 0 is just 0, so this is just 0, and from that we now have 3. So therefore, the answer for this improper integral is 3, and our integral is convergent. Okay, I hope you understand.